Hello. In this video, we're going to look at how to solve radical inequalities. Now, this is different from solving polynomial and rational inequalities in a few ways. We can't just really look at sign tables, but they do share some characteristics. First off, the domain is important. So our domain is going to provide some critical values for our solution. And the solutions to the equation that go along with the inequality, the corresponding equation, are going to define intervals. And then, like with rational and polynomial inequalities, we have to decide which of these intervals are included in the solution or not. It's just not as easy as looking at signs. So looking here at this first inequality, the square root of x minus 5 is greater than or equal to 3. We're going to first deal with the domain. So the domain here, we've got x minus 5 is greater than or equal to 0, which means x has to be greater than or equal to 5. So 5 is going to be a critical value, and in fact, there is nothing off to this side of it because x has to be greater than or equal to 5. So now to find if there are any other critical values, we have to solve the equation that goes along with this inequality. So in other words, we're solving the equation square root of x minus 5 equals 3. Now, I want to be very clear here. We are not solving this as an inequality. And that's because I can't just square both sides of an inequality and hope that that inequality will hold. So in most cases, in many cases, that would feel like it works. So for example, the inequality, let's say 4 is greater than or equal to 1. That is a true inequality. And if I square both sides of the equation, or the inequality, it is still true. 16 is greater than or equal to 1. But if I have something like 4 is greater than or equal to negative 7, that is also true, but when I square both sides of that, it is no longer true that 16 is greater than or equal to 49. This is actually false. So squaring both sides of an inequality doesn't necessarily maintain that inequality. So when I'm going to solve this to find critical values, I'm solving an equation, not an inequality. That way I don't have to worry about whether it remains true. Does the inequality switch or not? So this becomes x minus 5 equals 9, which means x equals 13. Remember, though, we do still have the possibility of extraneous roots. If this was extraneous, it wouldn't be a critical value. And if there are no solutions to the equation, then there's just the one interval, greater than or equal to 5. I check if the inequality is true or not, and I go on from there. But here, if I check 13, so is the square root of 13 minus 5, which is the square root of 9, is that equal to 3? It is. So this is an acceptable solution to this equation, which makes it a critical value for this inequality. X is allowed to equal 13 for this inequality because I want to know where is x minus 5 greater than or equal to 3. I'm going to note that x is allowed to equal 5, but it doesn't necessarily equal 5. So I have two intervals. I have the interval between 5 and 13 and the interval from 13 to infinity, and I want to check, is the inequality true in either of these intervals or maybe both of them? So what I do is I pick a value. So a test value, just some number that is in that interval. So let's say, for example, x equals 7 for that first interval and x equals 20 for the second interval. Now what I want to do is I want to test the inequality. Is the square root of 7 minus 5 actually greater than or equal to 3? So is this true? Well, the square root of 2 is definitely not greater than or equal to 3. So in this interval, the inequality is not true. So any values that I pick between 5 and 13 will not work. If, on the other hand, I use 20, is the square root of 20 minus 5 greater than or equal to 3? Well, the square root of 15 is greater than or equal to 3. So in this case, it does work, which means that my solutions are actually all of the values in this interval. And again, including the boundary because I am including when the square root of x minus 5 equals 3. So my solution is that x belongs to the interval 13 to infinity. So that's the basic idea here. Now, obviously, as our inequalities get a little more complicated, solving them might get a little more complicated, but the basic idea is the same. We figure out what is our domain. So 3x minus 5 has to be greater than or equal to 0. Domain is always going to be greater than or equal to, regardless of what inequality sign we have in our inequality, which means that x is greater than or equal to 5/3. So that sets the boundary. Nothing over here, 5/3, which may be a part of my solution if that interval is included, but I need critical values that go along with this. So I'm solving when is 8 minus the square root of 3x minus 5 equal to 4. These solutions won't actually be part of my solution, but they are going to define the intervals. So negative square root of 3x minus 5 equals negative 4. If I square both sides, I get 3x minus 5 equals 16. 3x equals 21, so x equals 7. I do want to check that this is an acceptable answer and not extraneous. So is 8 minus the square root of 3 times 7 minus 5 is 16. So 21 minus 5 is 16. This is 8 minus 4, which is equal to 4. So this is an acceptable answer. So I'm going to put it on my number line. It defines intervals for me, but it is not itself part of the solution. Then I test values. So a number in between 5/3 and 7. So let's go with x equals 5. And bigger than 7, so let's say x equals 10. You can pick any number in that interval. It really doesn't matter which one. So is 8 minus the square root of 3 times 5 minus 5 is 10. Is that greater than 4? Well, the square root of 10 is a little bit bigger than 3. So 8 minus 5 is going to be around 5. So 8 minus something a little bit bigger than 3. It's going to be less than 5, but it's going to be around 5. But the key is it's going to be bigger than 4. I don't actually care what the number is. You can, of course, pull out a calculator and check if you like. But I just need to reason out, is it going to be bigger than 4 or not? And it is. So this interval is going to be included. At this point, now that I'm including that interval, I am also thinking about the fact that I can include that boundary endpoint. If x is equal to 10, now what I have is 8 minus the square root of 25. So 3 times 10 minus 5, which is 8 minus 5, which is 3, which is not bigger than 4. So this interval does not work. For very straightforward inequalities, you're pretty much going to have an interval that works and an interval that doesn't. They're going to alternate, but you should check them because that isn't always the case. So in this case, my solution is that x can belong to the interval between and inclusive of 5/3 and 7, but not inclusive of the 7. So that is the solution.